Objectives of airbag. The main objective of an airbag is to lower the number of injuries by reducing the force exerted by the steering wheel and the dashboard, or any point on the body. This is accomplished in two ways: by increasing the interval over the force being applied, by spreading the force over a large area of the body. The airbag system has been engineered to work with the pressure between the passenger and steering wheel in a fraction of a second. The airbag unit must also stay intact at low-velocity collisions. The crash sensor, which detects the collisions and triggers the bag to inflate, must take all those constraints into account. The operation of deflation happens when N2 generation stops, gas molecules escape the bag through vents. The pressure inside the bag decreases and the bag deflates slightly to create a soft cushion. By 2 seconds after the initial impact, the pressure inside the bag has reached atmospheric pressure. In the modern epoch, airbags are almost present in every car. In order to mitigate the injuries due to car accidents, a variety of airbags are used. By making use of various types of airbags, road car accidents tend to decrease. An airbag is employed to prevent the major injuries that are caused by automobile collisions. The airbag will automatically inflate in less than a second in the event of a collision. Most of the airbags can be used only once. How airbags work? When a car hits something, it starts to decelerate, lose speed very rapidly. An accelerometer, the electronic chip that measures acceleration or force, detects the change of speed. If the deceleration is great enough, the accelerometer triggers the airbag circuit. Normal braking doesn't generate enough force to do this. The airbag circuit passes an electric current through a heating element, a bit like one of the wires in a toaster. The heating element ignites a chemical explosive. Older airbags used sodium azide as their explosive. Newer ones use different chemicals. As the explosive burns, it generates a massive amount of harmless gas, typically either nitrogen or argon, that floods into a nylon bag packed behind the steering wheel. As the bag expands, it blows the plastic cover off the steering wheel and inflates in front of the driver. The bag is coated with a chalky substance, such as talcum powder, to help it unwrap smoothly. The driver, moving forward because of the impact, pushes against the bag. This makes the bag deflate as the gas it contains escapes through small holes around its edges. By the time the car stops, the bag should have completely deflated. There are 4 main types of airbags: frontal, side, knee, and rear curtain. With continued research regarding safety, new types of airbags have been introduced recently, such as inflatable safety belts and pedestrian airbags. Front airbags are designed to protect the driver and front seat passenger. The driver's airbag is installed in the steering wheel, while the airbag for the passenger is mounted in the dashboard. When inflated, they keep a person's chest and head from coming into contact with hard surfaces in the vehicle. For front airbags to provide maximum protection, the driver and passenger should be sitting properly and wearing seatbelts. Modern airbags have a built-in sensor that detects whether occupants are wearing seatbelts or not. Many newer vehicles also have a front seat weight sensor that prevents the airbag from deploying if the person sitting there is young or small. Side torso bags are normally mounted in the seat. Their main purpose is to protect the person from smashing his body on the door and reduce injuries in the abdomen and pelvic areas. Side curtain airbags are installed behind the roof trim directly above the doors. They're designed to lessen the risk of head injuries. When side curtain airbags inflate, they normally cover the front and rear windows to protect passengers in both seats. Some more advanced curtain airbags have sensors that can detect if a vehicle starts to roll following a collision. Head-side airbags protect a person's head from hitting the object which the car has collided with. In high-speed crashes, people in the vehicle are likely to sustain knee injuries. Studies have shown that a person's kneecaps can shatter during impact. Knee airbags distribute the force of impact to prevent not only knee injuries, but also breaking a leg bone or bruising. They also help keep people in their position during a head-on collision, which reduces the force on a person's chest and abdomen. Rear airbags. During rear-end collisions, rear airbags protect passengers in the back seat. The rear window airbag prevents them from crashing into the back window, while the rear center airbag keeps passengers from bumping into one another. Seatbelt airbags. The purpose of this type of airbag is to spread the force of impact over a larger part of the person's body. At present, not a lot of makes and models make use of seatbelt airbags yet. Pedestrian airbags. Introduced in 2012 by Volvo, this exterior airbag inflates if the driver hits someone. Pedestrian airbags are supposed to reduce the number and severity of injuries that a pedestrian may suffer from. An airbag is an inflatable cushion designed to protect automobile occupants from serious injury in the case of a collision. The airbag is part of an inflatable restraint system, also known as an air cushion restraint system, ACRS, or an airbag supplemental restraint system, SRS, because the airbag is designed to supplement the protection offered by the seatbelts. Seatbelts are still needed to hold the occupant securely in place, especially in side impacts, rear impacts, and rollovers. Upon detecting a collision, airbags inflate instantly to cushion the exposed occupant with a big gas-filled pillow. In a frontal collision equivalent to hitting a solid barrier at 9 miles per hour, 14.48 kilometers per hour, the crash sensors located in the front of the car detect the sudden deceleration and send an electrical signal activating an initiator, sometimes called an igniter or squib. Like a light bulb, an initiator contains a thin wire that heats up and penetrates the propellant chamber. This causes the solid chemical propellant, principally sodium azide, sealed inside the inflator to undergo a rapid chemical reaction, commonly referred to as a pyrotechnic chain. This controlled reaction produces harmless nitrogen gas that fills the airbag. During deployment, the expanding nitrogen gas undergoes a process that reduces the temperature and removes most of the combustion residue or ash. The expanding nitrogen gas inflates the nylon bag in less than 1/20 of a second, splitting open its plastic module cover and inflating in front of the occupant. As the occupant contacts the bag, the nitrogen gas is vented through openings in the back of the bag. The bag is fully inflated for only 1/10 of a second, and is nearly deflated by 3/10 of a second after impact. Talcum powder or cornstarch is used to line the inside of the airbag and is released from the airbag as it is opened.
That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.